March 2019, paper 6. A chemist heated solid zinc chloride until it became molten. The apparatus shown was then used to pass electricity through the molten zinc chloride using inert electrodes. A silver-colored solid was formed at the cathode. Name the process of breaking down a substance using electricity. Of course, it's electrolysis. A Bunsen burner is used to heat the zinc chloride. Describe how the Bunsen burner is adjusted to give a very hot flame. Keep the air hole open or open the air hole. C. Suggest and explain expected observations at the positive electrode, which is the anode. Okay. Bubbles, because chlorine gas is produced. Since we're electrolyzing molten zinc chloride, so chlorine gas will be produced at the anode, and you will see bubbles. D. Suggest why iron electrodes cannot be used. They are active, they react with chlorine. You can say they are reactive or they react with chlorine. What difference would the chemist observe at the negative electrode if aqueous zinc chloride was used rather than molten zinc chloride? He would have seen bubbles because hydrogen is formed. Just saying that hydrogen is produced takes the mark. Of course, if you said that hydrogen is produced because it's less reactive than zinc, and that's why it discharged, it's perfect. Okay, zinc and hydrogen are present since the solution are aqueous, and the rule is that the less reactive element is discharged at the cathode. Double I, when electricity is used to break down concentrated aqueous zinc chloride, chlorine is produced at the positive electrode. Describe a test for chlorine. Litmus paper, or of course damp blue litmus paper, both are right. Bleaches. F, the bottle of zinc chloride is labeled corrosive. State one safety precaution that should be taken when using zinc chloride. Any corrosive substance, you should wear your gloves and goggles. Gloves or goggles takes the mark. Okay. An experiment. Question 2 is an experiment between solutions A and B of potassium manganate with solution C, and he used, of course, a measuring cylinder, which is an inaccurate apparatus. He added solution A to a burette, okay, and he filled the burette with solution A, and then he added from the burette the solution to a conical flask until the mixture turned pink, and he took the final burette reading. And then he took 2 centimeters of the contents and put them in a tube for making experiment 3. And finally, he rinsed the conical flask with distilled water. The readings are 16.1, 1.1, 15.0. If you didn't take the readings to 1 decimal place, you lose a mark. Experiment 2, he took the contents of experiment 1, poured them away, and the burette was rinsed with distilled water, and then he rinsed the burette with solution B. Experiment 1 was repeated using solution B instead of A. Final reading 31.9, 1.9, 30.0. CI. Which solution of potassium manganate is the more concentrated? Of course, it's solution A, since less volume of potassium manganate was used. Okay, when we read the experiment again, we find that he used solution A, okay, and solution B, okay? And then he filled the burette. He used solution A in experiment 1, and he needed 15.0 only from the solution to neutralize C, which is in the conical flask, okay? We have 25 centimeter cube of C, and we needed from A 15 centimeter. And the same experiment was done using B, but we needed 30 centimeter cubed from B to do the same job that A did with 15 centimeter only. So this means that A is more concentrated because we needed less volume of it to neutralize C. How many times more concentrated is this solution of potassium manganate? It's 2 times as concentrated or twice the concentrated, since we needed 15 with A and we needed 30 with B. So to get the ratio 30 over 15. DI, predict the volume of solution B that would be measured, would be used if it would be using 50 centimeter cube of solution C. Okay, he made the experiment using 25 centimeter cube of C, okay, and he used 30 centimeter cubed of B. Okay, so if he repeated using 60, which is sorry, if he repeated using 50, which is twice the volume he initially used, he will require twice the volume of solution B, which is 60 centimeter cubed, because he used twice the volume of C. okay, or double the volume of C. That's the explanation. Double I suggests a practical problem that using the 50 centimeter cube solution of C would cause. Of course, 60 centimeter cube, there is not a practical volume because it's more than what the burette can hold. So the volume of the solution is more than 50 centimeter cube, and the only possible solution to this problem is using more than one burette or refilling the burette. Question E, give one advantage and disadvantage of a measuring cylinder than a pipette. Measuring cylinder is easier to use and quick, but its advantage is that it's inaccurate or not as accurate as the pipette. Experiment 3, he added sodium hydroxide to solution C, green precipitate, and then after sodium hydroxide was added to the reaction mixture from experiment 1, reddish brown precipitate. Of course, this is iron 2, and it was oxidized into iron 3, the only two cations that have green and reddish brown color. So what conclusions can be drawn from experiment 3? That we have iron 2 and that iron 2 is oxidized into iron 3. Question 3, he has two substances, D and E. D was dilute sulfuric acid. This means we have sulfate as an anion and hydrogen positive ion. Okay, complete the observation. The pH, of course, from 1 to 3, since this is a strong acid. Don't use pH 0, please, because it's you never reach 0 pH. It's very hard to reach it. Number B, a strip of magnesium ribbon was added to the second portion of solution D. The gas produced was tested, okay? Magnesium ribbon in an acid will produce hydrogen, so we will see bubbles. The test is a lighted splint which pops. C, dilute nitric acid and aqueous silver nitrate were added to the third portion of solution D. The result, of course, is no change since we don't have halides. Finally, he added barium nitrate, which is the test for sulfate, and we do have sulfate, so it will give me a white precipitate. This solid E, the appearance is white. The pH is 10, so it seems like a basic solution. Hydrochloric acid added, carbon dioxide came out since lime water turned milky. When carbon dioxide comes out, we think in terms of carbonate, and it gave us white PPT insoluble in excess sodium hydroxide, which is indicative for calcium ions. Okay, this is very special for calcium ions. And then identify the gas produced in test 2, it's carbon dioxide. What conclusion can you draw about solid E? It is calcium carbonate. Finally, the experimental design. He wants to measure the rate of reaction between magnesium and hydrochloric acid, okay, by measuring the volume of hydrogen produced. He gave you a magnesium ribbon, dilute hydrochloric acid, and common laboratory apparatus. Of course, this is the diagram, magnesium in hydrochloric acid in a conical flask connected to a gas syringe to measure the volume of gas produced. The marks are on adding a certain volume of magnesium to a certain volume of hydrochloric acid and connecting a gas syringe using a stop clock to measure the volume of hydrogen each minute, repeating the experiment using different temperatures since he wanted to investigate the rate at different temperatures, and finally comparing the results. Of course, if more volume per minute was produced from the gas, this means that the reaction had a faster rate. This was March 2019 by Mr.